So here let us check how the user can define their own primitive and that can be used for developing a module. So let's say I don't have a basic primitive like where AND gate, OR gate, XOR, and XNOR. These gates are not available. Then, if I want to develop my own primitive, is it possible? Yes, it is possible. How is it possible? By developing a own user-defined primitive. So how it goes? We define with the primitive keyword and primitive name that I call it the test underscore prim. Then we specify the output and inputs. Okay. So here we can specify the output and inputs as A output is Z, input is ABC. So then we declare a table, a truth table directly by depicting a truth table. We can specify the function. A, B, C are the three inputs and Z is the output. And so it depends on the application, the Z will give the output 1 and zeros. Then in table and end primitive. Then at the end, if I declare my module as a top level module, which is called UDP underscore demo, and here also I specify the corresponding number of input and output variables. So where A is the output variable and X, Y, Z are the input variables. So to the test underscore print, optionally we can have a label and they can pass the values, output and input signals, that is A comma X comma Y comma Z. So after passing this, we will be able to see that uh, the ports are correctly it is mapped here, output to output, inputs to inputs are mapped here. So once we do this, we just select, we save it, then analyze our setup. So here we can check our module for any syntax errors. So now this is successful. Once it is successful, now we will check it whether we are able to get it. First, let us see the primitive. When an input is having only one, output will be one. If it is having two ones, output will be zero. When three inputs are there, it's going to have output one. So that's the combination that we are going to have. For odd number of inputs or ones in the input, it will give one. For the even number of the ones in the input values, output will be zero. Okay, so let us now check this with the simulation. So go to run simulation and select RTL simulation. So in RTL simulation, as usual, we expand our library. There we have a work and the top level module is UDP underscore demo and we can simulate it. As we simulate, we'll get the waves constituent to an object, then take these signals and add it to the wave. So okay, it's added to the wave, I guess. Added to the wave. Then here I arrange my output at the bottom. Then for this I pass the clock. So one let it go with 100 period and other one I let it to go with a period of 75. Then the three input, no, one more input I let it to go with 25. 25. Okay, 25 and click OK. X, Y, Z are the input, A is the output. So now if I run this, we'll be able to see that when all the three inputs are, I can zoom in here. When all the three inputs are one, output will be one. When odd number of ones are there, output will be zero. Then similarly, different combinations will be able to see that. So one is output. Then one, zero, one number, odd number of input, output will be one. And similarly, we can see the combination 0, 0, 1 where output is equal to 1. So if we don't have a primitive, then we can declare our own primitive when the basic primitives are not supported. Okay. So now let us look into the RTL schematic of this. So we can go. The functionality is satisfied. Now we'll check for the RTL schematic, how our code is being generated. So we can see that our code now generated like this. Then when you double click, you'll be able to see that for the given primitive, it takes some logics inside. Since we are not defined the logic, it takes the logic inside and it keeps the output. So without logic, it will not give. So this logic is automatically generated, and this is what we call it as a synthesis, translating our code into a valid circuit diagram is called a synthesis.